Hey folks, welcome on this cold, it's not cool, it's a cold day outside in East Tennessee, Western North Carolina, you name it, all across our state. Middle Tennessee, up there in Southeast Kentucky, it's bone chilling cold. It's November, can't believe it, can we? But hopefully you're warm and safe and toned inside and tuned into Mathline, okay? Thank you for tuning in this afternoon. I'm Ernie Roberts. I am your host. Chilly as it may be, we're here to have a good time, warm you up a little bit. So get around that TV, that monitor, wherever you're watching, and let's do some math together. Now, 844-686-2378, that'll really warm us up. If we can get those phones ringing a little bit here, get us going, and give us some math problems. I know a lot of you were out of school today. A lot of you were in half-day school, and so it's kind of a little chaotic and what have you. But you still got some math problems. You're all going back probably tomorrow morning, or at least on time, hopefully, or close to on time. Give us some calls. And let's check out our problem of the day while you're doing those. It says, what is the greatest common factor? That's a GCF, my friends, of the numbers. 48 and 120. Kind of big numbers there, especially 120. Looks a little intimidating there, perhaps. But we're going to look for the greatest common factor of those numbers, 48 and 120. Notice Facebook hadn't gotten a chance to really get in on this today, so I was kind of expecting to see a few answers, but maybe the weather has frozen the internet or something today. But nonetheless, we're going to look at it here together tonight, and if you haven't done it, take a look at it right now. See if you can come up with an answer. We're going to work it through, all right? So let's take a look at this thing. It says, what is the greatest common factor? There we go. GCFing of 48 and 120. Now, what's a common factor? That means a number that will divide evenly into both of these. Now, some people get that confused with that other thing called the least common multiple. We're not looking for that, okay? That would be bigger than probably both of these numbers together. I'm going to on a limb there to say that. And also, that's not where we're going, all right? But we could look at that. Could be another option if we don't hear from you when the problem of the daytime is over. But let's go ahead and take a look at what we have here, all right? 48 and 120. I like to do, it looks like a reverse division bar sign. I like putting our two numbers that we start with and give them some space. 48 and 120 here. And what we're going to do, we're just going to basically grind into these things. We're going to divide numbers in that we can see. I'm going to take it easy with it because a lot of us, maybe some struggle or whatever, so I don't want to push it too fast. But some of you may be jumping leaps and bounds into this thing and already found it. But let's take it 1, 2, 3, 4 steps at a time, all right? First of all, I'm going to take, and I notice that 2 is divisible into both of these numbers. I'm going to put a 2 out here because these are important numbers I'm going to be lining up out through here, all right? So we want to make sure that we get them all in there and we don't leave anything out because, remember, we're looking for a GCF, not just any common factor, but the greatest common factor here. So I can divide, because they're even, right? I can divide 2 into these very easily. So let's do that and move along. We got 24, and I have 60 there. I'm still looking at evenness here. I still have an even number. So let's cut it again. Let's go right on in and split by 2. I look at 2 even numbers. In fact, that's even better. We have 12, half of 60. How about it? Let's go to 30. Keep working with me, folks. Wow. Even numbers again. Some of you are like, my goodness, Ernie, how long is this going to go? Well, until we find the GCF, right? And we can't break it down anymore. Let's see what we got. We've got 2 going into 12. It's going to give us 6. And now we've got a 15 out here. Well, all of a sudden, we have an odd number, which helps a little bit in thinking, maybe not too much to go here further. I'm going to look at those 2 numbers. I've got 6 and I've got 15. My friends, what do you notice? Yes, I notice that 3 divides into 6 very easily. 2 isn't going to make it. And 6 isn't going to go into 15. So my only hope is 3. And 3 does divide evenly into 15. So I'm going to end up here with a 2 and looks like about a 5, all right? If we were reducing that as a fraction, that would be 2/5, okay? If we were pretending 48 over 120, that would be what we would use something like this for, is to get through those fractions reducing. But let's see. Why did I mark these things? Well, I'm going to mark them even more. I'm going to circle them. These guys down here, we're not going to worry about right now, okay? We'll check them out in just a second. But here's the deal. We know 2, 2, 2, and 3, and we're factoring it out. So we're going to multiply them. We're going to multiply the 2's and 3 together. So I'm getting 2 times 2 times 2, which is 8. Then we're going to multiply that by 3. So basically, my GCF, folks, by that calculation, says it's 24. So in other words, what I circled, multiply them. Now, check, check, check. We always like to check, don't we? If I do 24 times this last number 2, I'm back at 48. Checks out very nicely. What about 24 times the 5 here? Quick multiplication on that, we're back to 120. So we know that these aren't going to go any further. They're as far out as they go. So here we have it, 2, 2, 2, and 3. Multiply them together and get you 24. That, my friends, is your greatest common factor. And even though the numbers look kind of intimidating at first, as you start dividing by 2s, and some of you maybe even jumped in and divided by 4 and divided by 3 first off, that kind of thing, that will make things move a lot quicker also. But this helps you because the numbers get smaller and smaller until you finally, only thing you do, what's the GCF of this moment? What's the greatest common factor? It's a 1, okay? So you're done. That's how you know you're all finished up with it. When you pick up that 1 and you multiply those, there's your answer. So that's where we go. And where do we go with this from here? We want to hear some calls today, all right? We want to get some calls coming in here. That number is, we'll see it here in just a second, coming across the screen. There it is, 844-686-2378. You want to give us a call? Yes, you do. And talk with us. Tell us about how much snow you got, if nothing else, okay? Give us some calls. Let us know what's going on in your world. And give us some math problems that we can get into our world and your world both and work out together. How about that? Sounds like a winning plan, doesn't it? And stay warm at the same time, right? So once again, give us those calls. That's the numbers 844-686-2378. Quick warm-up. Speaking of warming up and trying to warm up, let's take a look at a quick problem here. Yesterday, we were looking at we've had some problems here lately that have been dealing with triangles, 180 degrees in a triangle. Then also, what happens when we have isosceles triangles? Well, this time we seem to not have just funky little triangles, okay? Isn't it true? So not isosceles because, well, let's find out. If you add these 2 degrees together, you get 120. And that means we're going to have 60 left over here, all right? Now, some of you are going like, how do you find x and y from there, Ernie? Well, there's a nice little pathway here. We call those vertical angles. Those vertical angles. From x to 60 or 60 to x, vertical angles are congruent. Because basically how they form is when 2 lines or line segments or rays, in this case it looks like 2 line segments, come together, and those are vertical angles. They lie opposite each other, and they are congruent. So we just found an answer. We just found an answer right there. We're going to put a 60 degrees right there on x. That was pretty straightforward, wasn't it? Now, how do we get to y? Once again, we got 180 degrees. Or you can look at it and say, well, we used up 90. So that means 60 plus something gives me 90 that's left over. So why not? Let's go with 30. And that works out pretty quick, all right? Remember, this little guy right here was 90 degrees because we have the little box. And up here at the top, a little less, 80, 40, 60. That checks beautifully, as does 60, 30, and the 90 there. So you have a little bit of idea. Always look for some sort of, when you've got a figure that overlaps, there's usually an easy shot somewhere in the middle, somewhere on the fringe or whatever. There's always something there that's waiting to say, if you'll use me, you'll get to the answer and get there very quickly, all right? So again, speaking of get through quickly, let's get some calls going, all right? 844-686-2378. Now, I'm going to, in a little bit here, I want to pick up a problem that was called in last Thursday, the last 2 minutes of the show. And we really didn't get an idea of what the problem was about. And our caller was calling in from Maryville, and I appreciated them calling in and giving us something. And we went through it after the show was over. It took about 10 minutes. I don't know if it'll take that long for us to rework it here, but we're going to look at it, what it looks like with a picture, what she had in mind, and also how we're going to solve it, how we're going to make it work. So again, first of all, we're going to hope for some calls here, all right? 844-686-2378. As I said, it's cold outside. It's a wet day out there, been damp and very cold, but you're around the TV, around your monitors, whatever. Watch us and give us a call, all right? That number, 844-686-2378, and we certainly would love to hear from you. So I'm going to go ahead and move that problem. We don't have any calls at this point, but let's take a look at what the problem was. If we get a call, we'll break in, work through it, and then come back and finish this thing out. You said, I don't remember seeing that picture, Ernie. Well, I didn't either, okay? When we were working through it, this is what finally was able to figure out they were talking about in the problem. And telling the young lady, she said, "Oh yeah, I have a picture." I said, "Oh, good. All right." So it pretty much wound up like what we were looking at. But the idea was we have an isosceles triangle, and we're going to call it A, B, and C here. And there was a circle that we call this an inscribed circle. If you'll notice, the circle's black. We've got kind of a little orange, brown, red, some sort of color that's coming across your screens at home, I'm sure. And we've got these things, what we call inscribed, where they are tangent. They touch at one point there all together. Now, somewhere in there is the middle of the circle. I'm estimating. I think it's about right there, okay? And what we're going to do, call that the end center. It's the center of that inscribed circle. And we're going to do a little work with this. We're going to pull a radius down here. I could also send a radius out here. And the truth of the matter is, this thing I should have made a little bit better. I got a little crooked there. This actually, because it is isosceles, let me try that again. We're going to make it work. Go through something like that. But keep in mind, you say, well, why are you doing that? Because she told me something about radius. She told me that the radius was 2. Folks, that's the only clue we had in this thing. Also, one more thing, we do get, oh yes, we get right angles coming through here. Now, what did she want to find out? She told me a couple of more clues. She said the degree measure down here was 50, and this was 50. So things began to work out a little bit. 2, also 2 here. Let me darken that just a little bit going out that way. And if we wanted to cut back this way, also 2. Because remember, well, trying to get to where it made a perpendicular. There we go. So all of these little radii moments are 2s, and they all go perpendicular to that side when it becomes a tangent, okay? When it's the radius tangent meeting together. So now the question is, you say, well, what was the question? We kind of lost track there. We're creating a problem. She wants to know, what is the length of BC? What does it equal? Well, question it. That's a good question. We also know that it's the longest piece of this triangle. Now, a couple other things here. Now, friends, if we can find one side, we will double it and we'll have BC. Okay? So maybe we'll call this thing, I don't know, we'll call this thing Y. Okay? Right there in the middle. So the question mark of question marks is, how are we going to get there? How are we going to get to YC? How are we going to get BY? Wow. We have a 2 and a 2 and a 2 over here if we should need it. Oh, by the way, if this is 50 and 50, what's going on at the top? 80 degrees. And by the way, it's going to split. So we're going to be 40 and 40 up there at the top. Now, the right angles come into play here. And I'm going to tell you right now, it's going to involve using trig functions. So some of you are like, trig functions. We had some Friday trig sessions, right? Sine, cosine, and tangent, working through them back through the early fall and even some in the summer with things. And so now we're going to say, let's put these things to use. And I understand we're going to let you all think and stew on this, and I'm going to give you a hint. We need to find out what this length from x to the center here is. Once we figure that out, if we add 2, we've got a big right triangle to the right, okay? It's got a 40, 50, and a 90. So what we need to do is figure out what's going on here. We'll do a little rounding, but we'll put it and add it to the 2. It's going to be fun, all right? We'll come back to that. I understand I have a caller waiting on the line. So welcome to Mathline this afternoon, this cold afternoon. Who am I talking with?
You're talking with Peyton?
Oh, Peyton, good to have you with us. And it's cold. It's cold up there where you are too, I bet, isn't it?
Oh, yes.
Cold outside. What kind of math problem you got for me this afternoon? I'm glad you called in. We appreciate hearing from you today, all right? And what have you got for me?
All right. If x equals -4, find y for the function. Y equals 2x squared minus x minus 8.
Did you say 2x squared, right, minus x and minus, what, 8 on the end?
Yes.
Okay, all right, we got that all clear. And the question is, we're looking for what? Find y?
Yep, find y for that function.
Okay, all right. And you gave me the value. It was -4, right? Negative
Yes.
4 is your value. All right, we're good. All right, just want to make sure. All right, folks, this is a little substitution problem here, Peyton. And you know what happens? Sometimes when we get a problem like this, we forget what to do with this negative when we start seeing in context with these minuses and these squares and stuff. So it's a good problem you're asking. And I'm not sure what your answer or your book has told you you're supposed to get for an answer, but we're going to see what happens here, all right, and see how we work through this thing. So how about it? We're going to say 2 times and something squared. I'm going to leave just a little gap right there, open parentheses, folks. And the same thing here. We're going to subtract that value, and then we'll subtract 8. Now, I put the little gap there because I want to make sure everybody understands we're replacing the -4 in there. So we're going to be squaring the -4, Peyton. You see that? You follow along what I'm saying there? Okay, you good? Great.
Yeah.
And we're going to do the same thing here. And I put that there because a lot of times students, adults, all sorts of folks who have a problem that looks like this, they just think, oh, it's got a minus, so you just put -4. And you're done. But it's really subtracting a -4, all right, which is going to play a little game with us here, all right? And the same thing's going to happen here. When we square a -4, we're not going to get -16, as your calculator will tell you if you don't put parentheses around that -4. So again, calculators are a wonderful thing, but sometimes you've got to tell them what to do because they just assume what you show them, and if you don't put the right parentheses in there, it's not going to work. I digressed a little bit. Sorry about that. Now, let's talk about it. -4 squared. I'm going to get 16, and it's going positive, which is a nice number there, okay? I'm going to do the same thing here. It looks like I'm going to be adding the opposite, which is going to make this become plus a +4. So we're going to put it down here, +4, and then we'll have eventually subtracting 8. That has not budged, has it, on the end? The -8 or the -8 is still right where we want it. Is that good so far for you? See what I've done? Make sense?
Yeah.
All right, good. Now, from here on, it's pretty easy. We're going to double 16. I bet you could do that, but I'm going to go ahead and move it forward here for us. It'll be about 32, I think. Does that sound good?
Correct.
All right. Adding 4. And then we'll subtract 8. We'll just work this thing left to right. It's going to be fine. We're going to say 32 plus 4, which gives us 36. And let's go ahead and subtract 8 from that. I think you're going to end up with 28. Does that sound good?
Mm-hmm.
Let's see. Let's go to the calculator just to kind of see there. And then plus the fact, I always like for y'all to see that some of these things you can do on a calculator. So let's go there. And the function was 2x squared minus x minus 8. I'm not going to go to trace or type in the whole function, but what we're going to do, we're just going to put in the numbers here. So let's go with that -4. By the way, the negative's at the bottom. That's not the subtract is here. This is negative, so that's kind of important. We put that in there. So let's put that in there. And Peyton, you said squared, right?
Correct.
So I'm going to hit x squared there, and that just simply squares the value I've got there. Notice the 2's outside the parentheses, so it should be happy and healthy, okay? We got to subtract. This is where I like to show this little business. There's the subtract. Now let's put that -4 in there. And we'll close it off. And then we'll pick up one more subtraction symbol, and that's subtracting with 8. Now, folks, a lot of these things you can do in your head, which we just did or we worked through, and I know that works. But I also just want to emphasize, if you do not put parentheses around that -4, calculator does not see it as being -4 squared. It's going to square the 4 and then tack a negative on. You've got to be careful on that. Same thing here. If you just put minus and put a 4 in there, and you might be able to take away the parentheses on this one, probably not have a problem, but since we used them on the paper, we're just going to use it here. But this one definitely, when you're squaring or running a 4th power, you've got to have that parenthesis around there if you're going to use your calculator, okay, and it's a negative value. Or you can just remember the rules. If you square a negative, you're going to get positive. If you take a 4th power of a negative number, you're going to get a positive. But again, your calculator doesn't do it unless you tell it, okay? I'm hoping we get 28. I've sat here and rambled on it. There it is, all right? So it does check out with our calculator also. But, you know, like I said, though, mental math, we can do a lot of this in our head. And like I said, the -4 squared, just again, remember, you do get 16 positive, and you can work that on through down there, okay? So thank you, Peyton, for that. And again, hopefully we'll get some more calls in this afternoon, all right? I know it's cold outside and people are all bundled up, but hey, let's do some math and warm you up also, okay? Thanks for calling today. And let's see, while we are back to this problem I was going to look at, let's see if we can get this done here. We've got about 5 minutes, and if you call once again, we'll take a little bit off here. But I'm going to draw off to the side here a little bit. We've got a big triangle, the right side of the figure, if you will. And over here we got about, it's not quite, it's a little bit more, all right, yeah. It's a little bit further than half away because remember, this definitely picks up the radius plus a little bit more, and that's just the radius. So we know it's a little bit more than, you know, than 2 there. And again, we've already put our numbers as 40. This is a 50, by the way. Did you notice that? That's a 50 because it's a right triangle. Remember we did that little exercise a minute ago with the triangles and how many degrees were in there. So you got a 50 right there, and we got a right angle here. Now this is where we're going to play the trig. We already know this is 2. We already know this was 50. And friends, this is a big old whooping right triangle. So what we're going to do, if we can figure this little part right here, I'm going to call this x, we're home free. Because what we're going to do, we're going to add it to 2, and then we're going to do a big trig function there. So it's going to be trig twice, all right? How about that? Trig twice. How about it? Let's look at it. So what do we know? We know a 2 right there also. So I'm going to go with, since it looks like it's the opposite and hypotenuse here, everybody see it with 40? I'm going to go in that regard. So we're going to say the sine of x, which in this case is what? 40 degrees. What we got here, the little thing here, is equal to 2 over x, okay? Opposite over hypotenuse. Little right triangle here, okay? And we're going to drop a little 1 under there to help us out some, because when we cross multiply, it will help us. Now, this is definitely where you want your calculator to come into hand. That's where they're great. They really do a great job on these things. So let's see what we're going to do. First of all, let's go back to my problem here just a second. Sorry, I got them all excited there. We're going to cross multiply first, all right? So what we've got here, we've got the sine of 40 degrees times x equaling to 2, because that's what happens when you cross multiply here. And we're going to basically say that x equals, almost off my page, isn't it? 2 divided by sine of 40. Now make sure your calculator is in, let me pull that up just a tad. Sometimes these problems take a lot of room. Let's go to 2 divided by sine 40. And I did say something about make sure that you're in degree mode. And it looks like it's about 3. Like I said, it was a little more than 2. Looks like it's about 3 point. We'll go with, how about it? Let's go to the nearest tenth on that. We'll take it 3 1/10. So it's approximately 3 1/10. So there's our little value right there. Now, we're going to play the game again. You say, oh, wow, are we? Yes, we are. What are we trying to figure out? We need to figure out this little part. We'll call it y. Why not call it something different? How about it? Let's call it z. And we'll say this little length right here from y to c is equal to z. And what we're going to double it. Whatever we get there, we'll double, and we'll have the length of BC. So to our caller from Maryville last week, that's how we're working this out. We're in good shape here. Let's use this as 5 1/10. We're not going to have enough time to finish it, but that's okay. And we're going to use our little z here. What's the relationship? Well, it looks to me like it's opposite over adjacent legs. So it looks like we're going to take this over z to equal, am I on the page still? Good. The tangent of, what is that, 50 degrees. Again, that's our good old tangent formula. Opposite over the adjacent leg, and that's what we're looking for there, okay? Now, we're going to figure that out. We'll bring it back to you tomorrow because I'm understanding we're getting close on time here. We're going to go ahead and wrap the show up today here. We will put that together for tomorrow, and we'll get that for you and finish it off. And you're going like, whoa, that's a crazy problem. It is. And my friends, not all problems can be solved in 3 or 4 minutes. And especially when we got that one about the last minute and a half. So like I said, it took us about 10 minutes for working it out together on talking to each other, but we'll get it for you finished off tomorrow. So thank you for calling in those kind of problems. We appreciate them too. Now, 30 seconds left we have. I want to remember and tell you Facebook, please check us out there, all right? Like us, love us, and share us. www.facebook.com, it's /Mathline. Of course, YouTube also, we have those things going there. We got some of our old videos out there that you can check up and get some practice, all right? Some of our specialized segments, that's what they do. They drill and practice a lot of things. In the meantime, you can always give us a call. We'll be back in tomorrow and same time. And my friends, I'm looking forward to seeing you then.